Hey everyone, my name is Adam Keller and I'm a developer advocate on the container services team here at AWS. And let's talk about optimizing your applications for scale on Amazon ECS. Today we're going to approach this from several angles. First, we're going to look at the foundation and we're going to talk about building for scale and what that means. Next, we're going to look at scaling the process. We'll talk about deployments, deployment strategies, as well as scaling the application itself. Finally, we'll look at scaling the infrastructure. We'll focus on application-first thinking and discuss ways to achieve running at scale while offloading the heavy lifting. I'd like to start by taking a look at a likely workflow for someone new to the service. We all start somewhere. Oftentimes we start when we're first building in a service in AWS, we start by building in the console. And this is a great entry point, super helpful with getting started. But what happens when you go beyond testing or learning? Well, if you stay in the console, you build one cluster, then another, then a couple more, then a few more. Then you start building in multiple accounts, multiple regions. Okay, hard stop. How do you repeat what you've done? Most likely one will forget what they did, and even if they document the steps, there's still a good chance you're going to miss a step when you're manually doing things. This frankly just doesn't scale. And hence the need to automate and build for scale, because one person can't be the bottleneck. And this is why it's important to build in ways where you don't repeat the same things over and over again manually, and instead automate those steps. So let's talk about some ways that we can achieve that at scale. So in order to build for scale, you need to automate your environments. And while this is critical, it's equally critical that you build with your team in mind and build to their strengths. Running at a high scale doesn't mean to build and run thousands of containers or thousands of nodes. While that's a good part of it, it's also about building a process to enable teams within the organization to build on repeatable patterns. This reminds me of Conway's Law, which in short states that most likely what you build is going to emulate how you culturally operate and communicate as an organization. For example, if your teams are very developer focused and prefer to write code, let's say using TypeScript, use a tool that's going to enable that team or those teams to be successful, like the AWS Cloud Development Kit or the AWS CDK. On the inverse, if your structure supports a centralized platform team that prefers JSON or YAML as their language, or wants to build more of a platform to vend to different teams, look at something like AWS CloudFormation or Terraform, and look at services like AWS Proton, which we just released in preview, to vend environments and services to your development teams in the organization in a self-service model. Back when I was leading platform engineering, I constantly thought of my customers, developers and operators, and in order for us to be successful, we needed to build in ways to empower them to move fast and not be bogged down with all the intricacies of the infrastructure. So the self-service model fit best in our organization, and we built the products which were available in a self-service model to our teams to vend as needed. But even with automation, there's still going to be an expected understanding of the environments and a knowledge of the platform that you're building on. And this is why we always recommend to leverage opinionated tools that abstract the boilerplate, taking advantage of good practices. I will always, throughout the talk, say good practices. I tend to avoid saying best because I think good practices consistently evolve. And enabling you to focus on what matters, which ultimately is your customers and your business. So you've likely heard the term GitOps. So we're going to talk a little bit about deployment strategies throughout this talk. But ultimately, GitOps boils down to using Git as the source of truth for your deployments. This means you store your environment's configs in version control, and the deployment is triggered off of a merge to Git. More on this later, so stay tuned. But let's dive into some tools that are available right now to enable automation and automating at scale. So it starts with using the right tool for the job. You've heard Werner say that many times, but we first have to ask ourselves, what level of management and ownership do we want over the platform? And what I'm going to do is build a pyramid. And we're going to start with the base of the pyramid being the heaviest lift, with the peak being the easiest. So starting with the bottom layer, this is where you generally start. We'll play around in the console. You learn, you build, and so on, as we talked about earlier. And then as you get comfortable, you start to automate. Maybe, you write some bash scripts with the AWS CLI. Or maybe you do a little Python and you start using Boto 3 in the AWS SDK. And this is all great. However, I need to have a pretty good understanding of everything that I'm building. This means that if I build a VPC, I have to set up routing tables. If I set up a load balancer, I have to understand target groups and connecting my services to those target groups. So not only do I have to have the deep understanding when I'm using the AWS console or the CLI or the SDK, but I also have to be able to write error logic and manage the state of my environments to keep track as things change and drift occurs. And this is generally when one graduates to the next layer, which is where we have state management as well as environment awareness. And this is where we start talking about CloudFormation and Terraform. Now, these are tools that are built with managing state and reproducibility as the first-class citizen. So your environments are defined as code, and that code is declared as JSON, YAML, or if you're using Terraform, it could be HCL, which is the HashiCorp language. And these tools essentially build on top of the base layer. So AWS CloudFormation behind the scenes, it's making API calls to create and check on resources. And Terraform is using the AWS SDK to provision and manage resources. But both of these tools not only are creating resources on your behalf that you've declared in your code, they're also checking on the state of your environments. So state is really key here. The problem with these tools is it still requires a deep understanding of all the resources that are being built and created. Meaning, you need to create your networks, your VPCs, your load balancers, security groups, IAM policies, roles, and so on. This can be heavy, and depending on the experience you or your team has, it may be too daunting and overwhelming. And this is where we move to the top of the pyramid, and we look at tools that are opinionated by default. So what does opinionated mean? When we talk about opinionated tools, these are tools that obfuscate the boilerplate from you and implement the underlying components using good practices. This means that you don't have to be an expert from A to Z, and rather you can focus on solving your problems and deploying your application within a clearly defined spec. So we have AWS Copilot and the AWS CDK here. AWS Copilot is a CLI or command line interface that essentially enables customers to quickly launch and easily manage containerized applications on AWS. It provides a simple declarative set of commands, including examples and a guided experience built in to help customers deploy quickly. More on this coming in the next slide. And then there's the AWS Cloud Development Kit, the CDK. This is, by the way, Copilot and CDK are both open source projects. And the CDK is a framework that enables operators or developers to define your cloud application resources using familiar programming languages such as TypeScript, JavaScript, Python, and Java, etc. So by using the familiarity and power of the programming languages for modeling your applications, it provides the users with high-level components called constructs. And these constructs pre-configure cloud resources with proven defaults, also known as good practices, built in so you can build your cloud applications without having to be an expert. So these tools build on top of that middle layer. So the CDK, Copilot, they build on top of CloudFormation to deploy and track state of the infrastructure, as well as Terraform with the CDK TF project. So this is an example of running through AWS Copilot. A simple Copilot init command is going to walk you through an experience and ask you questions about your environment and application that you want to deploy. Once you go through the guided experience, it's going to build the environment for you once you approve it to do so. This means that I don't have to be an expert in anything outside of my application. So I have my Docker file. I know how my Docker file runs. I know I need to expose it on this port, and that's it. Copilot handles the rest of building and managing the environments. So once I've built my environments, Copilot then gives me a manifest file. This manifest file is a simple YAML declaration of my spec of how I want my container to run, what port, resource allocation, environment variables, secrets, etc. The nice thing about Copilot is it goes a step further and it helps me to build a pipeline. So if I want a pipeline enabled for continuous delivery, continuous deployment, Copilot can do that on my behalf as well with a simple Copilot pipeline init. So the bottom line is, when I talk about opinionated, we're building full environments that are production ready, scalable, highly available, using good practices that are built into the tool by default. So let's jump ahead to the CDK. So in the CDK here, if you prefer to avoid YAML and JSON and you want to write everything in a familiar programming language, the CDK is for you. And we mentioned constructs earlier. So these higher level constructs enable you to create resources with a simple interface. So in the example here, we're creating a load balance Fargate service with all the network components, security groups, IAM policies built in. And as you can see, I have 19 lines of code defined, and those 19 lines of code are going to generate over 1,000 lines of CloudFormation. So we're taking advantage of good practices built into the tool, and I'm just focused on my application and what matters to me, my team, and my business. And by the way, with Copilot and with the CDK, as you grow, if there is a default that doesn't fit your needs, you can override it, as well as extend the tools to meet your needs. So the next thing I want to talk about is understanding your application. So state of the container itself is really important to understand before deploying your containers to an orchestrator. Do I need to store state in the file system? If I do, we're going to have to consider, where do I deploy my container? If I can use a shared NFS file system like EFS, then Fargate would work. But if I need something more like an EBS volume, or there's something where I need to track state more heavily, then maybe EC2 makes more sense. And truth be told, at the end of the day, we should be looking at containers as stateless, and we should treat them as such, as ephemeral pieces of compute that run and operate, and when they don't work as expected, we kill one off and a new one will replace it and continue the pattern that it was practicing and doing what it needed to do. So ideally, decouple state from your container when and where you can. And this is using services like DynamoDB. If you need a database, look at RDS, the relational database service. Elasticache for if you need a cache layer, and so on for Redis and Memcached. Next, it's important to understand monitoring and tracing. What's important to my application? Is it uptime? Is it low millisecond response times? Do I need to rapidly scale? These are all important to understand, because then you need to understand what metrics you're going to have to use to scale your application. So when we talk about metrics, we'll go into this in just a couple slides, but it's really key to understand what is going to be the point of scale for my application. And lastly, health checks. It's really important that you health check your containers from the get-go. So there's a couple different ways you can health check your containers in ECS. So one is using Docker health checks and setting that in your task definition. This enables me to actually run a command in my shell in the Docker container to check the health of my service. So if I have a health shell script that I want to run, or I can always just also curl against that command against the container as well to check the health, and then report back an exit code of unhealthy if it's not operating as we expect. Now, this is really good if your application is not behind a load balancer, but if you're using service discovery, or you just have a container running, health checks, defining that health check in your task definition is critical. Then there's load balancer health check. So if your service is behind an application load balancer, you want to have a health endpoint to determine the health of your application, because the load balancer logic will actually look at the health. It'll query the health check endpoint. And if at any time your application is not reporting healthy, and then it reports past that failure threshold, the load balancer will take that container out of the pool and not serve traffic to it. Now, there's one critical piece here when health checking that I wanted to point out. When running microservices in a containerized world, we shouldn't be health checking the status of the database, the status of all the services around us that we need to communicate with. The focus is health check the status of your application and rely on the health checks of the other services and other components to be responsible for checking themselves. Because what happens if I have 10 services, they all look at the same service or database, and that database or service is not responsive? I now have 10 services that are constantly fluctuating and killing off, coming back, killing, coming back, because they're not able to access the back-end endpoint that they're supposed to talk to. So this is really important when you're creating health checks and thinking about how you're going to health check your applications. So now I want to move to scaling the process, and I want to talk about modern deployments. Deployment strategies, they've evolved over time. We went from automating with bash scripts, using SSH or SCP to push files to servers, restarting the services, and then SSHing to make sure they're up and healthy. Then we moved to config management, where we had Chef or Puppet or Salt or Ansible help manage our deploys. And as we've evolved to more modern deployment mechanisms like continuous integration, continuous deployment, we've kind of arrived to the latest, which is GitOps. And at the end of the day, this evolution just naturally occurred because we realized deploying from someone's laptop, having multiple tools to manage the deployments, it's clunky, it's heavy, and it didn't scale well. So what's the moral of the story here? Well, don't deploy from your laptop. Don't have release engineering teams dedicated to pushing a button when they may be deploying something that they don't really have familiarity with. So the next iteration of the deployment methodologies, it has arrived to GitOps, and we're going to talk more about that later. But again, it's with the focus of storing your environment's configuration in Git and using Git as the source of truth. So we're going to talk more about that in the next slide. Lastly, I just want to say that monitoring and testing are equally as critical to this process. In order to have more modern deployments, you need to have automated tests that will test during the deployment of your code, as well as post-deployment. So really important that you have automated tests integrated in your pipelines and monitoring post-deployment to ensure that you're healthy, your applications are healthy and running as expected. So this is an example of a GitOps workflow with, of course, Git, version control and that Git repository being that source of truth. So first we have a developer submits a pull request, team reviews it. Maybe on that pull request you have automated tests. So if your code that you're proposing will work as expected with the testing framework that's enabled, the pull request will show that, hey, this has gone through our automated tests, now it's ready for review. So once you review, the team reviews, whether that's 1 or 2 plus ones, and once you have that review, you merge the pull request. Once that pull request is merged, the deployment process kicks off. The build and deployment process kicks off. And the goal of this process is to keep your communications, your history, and your configurations of your deployments in one place, and that's version control. Why does that matter? Well, I have the ability to store my all my code and my configurations in one place, so it's a single source of truth. I don't need a release team to manage and push these deployments because it's using a familiar tool, which is Git, which developers are using for the most part, right? And my change review process is all logged and recorded in Git history. So I know if a change was submitted and it was a breaking change, I know who did it when it was merged, and we can see exactly what they changed so we can roll forward as quickly as possible. So now we talked about automation, we talked about deployment pipelines, but the next piece to really dive into here is the deployment strategies. So with ECS, there's a couple different ways that we can deploy our containers and using a couple different strategies. First of all, manually deploying in the console, that's not a strategy. Please, let's not do that. But let's talk about rolling deployments. So a rolling deployment is essentially taking the percentage of healthy tasks and saying how much over that percentage of healthy tasks are we willing to allocate for this deployment to occur. So this is why knowing your service matters. I talked about that earlier. Is speed critical? Well, if speed's critical and uptime is not critical, as critical, meaning it's not a front end app that's constantly serving customers. Maybe it's an application that's reading from a queue. So if I kill off most of my instances, my tasks for deployment, that's okay, because when they come back, they're going to start churning through that queue again. We'll talk more about those percentages and what they mean in the next slide. But then there's blue-green. So ECS integrates with AWS Code Deploy, and you can use blue-green, which essentially blue-green is where you deploy the new deployment, the new application in parallel, health check it, and then flip over to that new deployment once it's healthy. But there's also iterations on blue-green that we can take advantage of, such as linear deployments, where we say we want to slowly roll this deployment out, n percentage at a time, or two, where we want to just do a canary deploy, where I do a small subset, I bring a small subset of that traffic, or I'm sorry, of that application to serve traffic, maybe 10%, and once that's been healthy for 5 minutes, we then shift the rest over. So looking at rolling deployments, the goal is to roll out new services while still meeting that desired minimum healthy service count until the new replacements are healthy and we can start killing off the old ones. So if you look at this example here, we have a strategy of 100% minimum healthy tasks and 200% max healthy. This means that when I have my new version of my service and I deploy it, we're going to double the task count essentially, ensure that those are healthy, and as soon as those are healthy, we're going to kill off the old tasks to ensure that we're always at that 100% mark for our deployment. And with that, we just recently announced circuit breaker functionality. So with circuit breakers, ECS, the scheduler, now has the ability, now this is something that has to be enabled. So when you deploy, this isn't enabled by default. And what the circuit breaker would do is it will track the deployment as it's iterating. And once there's a threshold of failed tasks, it will recognize that these tasks have failed, and it will consider the deployment a failure and mark it as failed as the rollout state. Now, if you enable automated rollbacks with the circuit breaker functionality, what the circuit breaker will do is it will roll back to the previous healthy deployment of that service. So from an operator perspective, this makes a lot of sense because I'm letting the circuit breaker manage the health checking, and when tasks fail, it will automatically roll back for me. So there's a lot of power there. And note that that service is in preview. However, we're continuing to build on it, so please test it out, give feedback as you use it. With blue-green deployments, essentially it's going to provision a new set of containers. So I start a deployment, a new set of containers will come up. Now, Code Deploy is going to look at the CloudWatch health checks. It's going to deploy on another port, another load balancer, that same load balancer. Once it's healthy, Code Deploy will then switch from blue to green, which is our newest deployment, and shift traffic all the way over to that new deployment. And that's pretty much it. If with blue-green, if you wanted to do linear, as I mentioned, or canary, it would be a slower shift, a slower process. But I definitely recommend that if you have applications that are super critical with uptime and very sensitive to any downtime or degradation, it's important to look at something like a canary deployment where you can slowly roll out that functionality, and if it fails, it only affected a small subset of your user base, not everyone all at once. And once your service is deployed, now your application's running in ECS, auto-scaling your service is really going to help enable teams to not have to go into the console or issue a CLI or an SDK call to scale your service up and down. With service auto-scaling, as long as you know what those metrics are that are important for your application to scale, you can integrate. The ECS integrates very nicely with CloudWatch metrics to use for auto-scaling your services. So if you don't know what those metrics are, on day one, that's okay too. So out of the box, you get CPU, memory, network metrics as well that you can use to scale your services. But if your service is behind a load balancer or you're talking to an SQS queue, you can also use those metrics as your auto-scaling patterns as well. So it's up to you, but of course, if somehow these don't fit the default out-of-the-box metrics, you can always create your own custom metric in CloudWatch and use that as scaling. Now, I want to talk about scaling policies just for a second here to explain that the two different types of scaling within auto-scaling and ECS. So first, there's step scaling. With step scaling, this is essentially going to, you set the step size, let's say it's 2, and every n minutes, it's going to scale 2 tasks until you hit your threshold. With target tracking auto-scaling, you designate a target. So if my target is, I need to make sure that I have enough tasks to always serve no more or no less than 10 messages in the queue at a time, target tracking is going to exponentially scale to meet the demand of your application. So if I scale, the first iteration, it scales with target tracking, it's not enough, it's going to scale more, and then it's going to go more aggressive as it scales out to ensure that it can hit that target number at all times. Okay, so now we're going to move to the infrastructure. And, this is always fun little joke for the audience, but when was the last time you upgraded your control plane for your Amazon ECS clusters? The answer is never, because the control plane is fully managed. Updates are available without having to perform any upgrades to the control plane itself. Now, of course, if you have EC2 in the data plane and there's an update that you want to take advantage of, that you may need to update the ECS agent, of course, but there's no management or upgrades required for the control plane. And as we talk infrastructure in ECS, we build with the tenets of thinking application first. And this means that applications own their requirements and infrastructures respond to the application requirements. And one component is, we talked about service auto-scaling, but if your services are running on top of EC2 instances, when your services scale out, your instances need to scale out too to meet the demand so we can schedule those tasks onto those instances. And this is where capacity providers come into play. So if you're using Fargate, there's the Fargate and Fargate Spot capacity providers, which come out of the box. This is just there. You can't delete it. You can't change it. But if you're using EC2, then there's the concept of a capacity provider that has cluster auto-scaling. And this is where it consists of a name, an auto-scaling group, and then the settings for your managed auto-scaling. But this is where we now start to abstract the management and ownership of EC2 instances. And while we still own the EC2 instances, patching them and so on, scaling them out and in, we have now offloaded that heavy lifting to capacity providers and to ECS. So just a quick idea on the setup. When you create a capacity provider, you create your cluster, you create your auto-scaling group, you create your capacity provider, which points to that auto-scaling group, and then you run your tasks, you associate them to an auto-scaling group. It's going to, if there are no instances in that auto-scaling group, it will spin up the right amount of instances to meet the needs of your applications and your tasks. and then ECS is going to schedule them onto those instances. So I have a little walkthrough here that I want to show, and this is an example of kind of a live scenario with ECS using capacity providers. So I have my service, and now my metrics are starting to go up, and at some point now we've hit an alarm where we need to scale. So the ECS service auto scaling is going to kick in. It's going to scale out to meet the demand, but now as we've dropped in utilization, we still need more scaling to happen and more tasks to come up. So more tasks are launched. However, now we've gone past the point of availability within my EC2 instances in the cluster. I don't have any instances to schedule these tasks onto. So capacity providers are going to expand the auto scaling group, bring in the right amount of EC2 instances to schedule those tasks, which will then ensure that our services can run. Now the demand has dropped, our metrics are good, and now our alarms go away and we're where we need to be. So the idea here is we were able to scale our services and our infrastructure all at the same time using capacity providers. At the same time, roughly. So now I want to just talk about some placement strategies. So there's a couple different options when you're placing your ECS tasks on EC2 instances. So there's random, where the scheduler doesn't really care. It's just going to schedule a task on whatever EC2 instance is available, which is okay. But then there's bin pack, where we want the scheduler to pack as many tasks onto an EC2 instance as possible. And then there's spread, where we say we want to spread across multiple availability zones to ensure the highest availability possible. So depending on your use case will determine how you want to deploy and what strategy you want to use when placing your tasks. So I'm not going to dive into app mesh, but once you hit a certain scale, a service mesh does make a lot of sense. And with AWS App Mesh being a fully managed service mesh, I highly recommend looking at some of the other reInvent talks where we dive deeper on App Mesh to see if that a service mesh would make sense for you. And lastly, I just want to touch on understanding service quotas, know what's adjustable versus what's not, plan ahead, and always set alarms to ensure that you know that you're ahead of any possible limits that you may come up to. And lastly, I just want to talk about monitoring and metrics just very briefly. CloudWatch Container Insights, if you enable this on your cluster, this gives you a really nice view into your ECS cluster, your tasks running on Fargate or EC2. And essentially, it collects, aggregates, and summarizes those metrics and logs from your applications into a single pane of glass. So this is just an example of a cluster I had running. I can see all the statistics around that cluster in one dashboard. And of course, I can also drill down into services or tasks as needed. And for your application tracing, I highly recommend looking at something like AWS X-Ray, where you can have tracing built in to your application. Of course, understanding your code and knowing where you need to add your own custom tracing versus where tracing is automatically enabled. Definitely check out AWS X-Ray to get some more insight into that. But it integrates nicely with other AWS services. So if you're talking to a DynamoDB table and so on, it's the way to go. And lastly, I just recommend checking out the partner ecosystem, partners such as Datadog, Dynatrace, New Relic, etc. We have container competency partners that are here to help and ensure that your experience of running containers on ECS is as smooth as possible. And please check out our workshop, ecsworkshop.com. We walk through a lot of the things I talked about and with a lot of the tools that I talked about. And then there's Containers from the Couch. We go live pretty much Monday through Thursday every week at 12 o'clock Pacific time. We talk about all things containers on AWS. And of course, check out the Containers Roadmap. If there's a feature you want that's not there, or you want to submit a feature request or +1 a feature request, that's the place to do it. Otherwise, that's it. Please follow me on Twitter at RealAdamJKeller or on GitHub at AdamJKeller. And I just want to thank you so much for spending the time with me today. And please do complete the session survey at the end And please reach out, ask questions. I love talking about containers. I love talking about ECS, anything on AWS. So thank you so much, and have a great rest of your conference.